Do you know what's sitting between your modem and the rest of your network? Like if your internet went down right now and the ISP said, it's not them, would you know where to look?
Yeah, for a lot of organizations, that question just highlights a massive blind spot. I mean, the perimeter edge is, it's often completely ignored until it fails catastrophically.
Right. Welcome to the deep dive. Our mission today is to unpack a real-world network failure that actually happened to a local business over on Oahu.
It's a really fascinating one.
It is. We're looking at a case study from the Cowabunga Computers blog. It details this severe outage caused by a completely dead Cisco firewall, and then the strategy they used to replace it with a UniFi system. So we're going to explore the mechanics of network hardware failure, the choices between multi-vendor and unified ecosystems, and the warning signs before your site just goes completely dark.
Yeah, and the initial scenario here is something almost any business owner or, IT manager has faced at some point. The site just loses connectivity. Right, completely. Point of sale systems drop, the VoIP phones unregister, cloud applications just time out. And the immediate reaction, which makes sense, is to call the internet service provider, right? They assume it's a localized outage or an issue with the line.
Exactly. So the ISP runs the remote diagnostics, they ping the modem, and they report back that everything is perfectly fine on their end. They verify that bandwidth is reaching the demarcation point.
Mm.
And that phrase, the problem isn't on our end, it just shifts the burden entirely.
It really does. It's a terrifying phrase if you don't have an IT background.
Oh, absolutely. Because the ISP owns the infrastructure right up to that modem. But the exact moment the Ethernet cable leaves their hardware, it becomes your internal network's responsibility.
And that demarcation point is exactly where the technician from Cowabunga Computers, Brandon, where he began his diagnosis. So he arrived on site and basically had to trace the logical and physical path past the ISP's gateway.
And what did he find?
Well, he found that the client's Cisco firewall had completely hard faulted. Like completely dead. It was totally unresponsive to console access, dropping all packets, and, power cycling the unit did absolutely nothing to restore the routing engine.
Wow. So just a total brick.
A total brick.
And a total hardware failure at that specific node is just devastating. Because, a firewall isn't just a passive filter sitting on the wire. I always like to think of it like an analogy. It's like a specialized bouncer at the door of an exclusive club.
Oh,
right?
That's a great way to put it.
Yeah, so if the bouncer just passes out at the front door, no one gets in or out, it doesn't even matter at the street outside, like the ISP's connection is completely clear and empty.
Yeah.
So can you elaborate on what a firewall actually does beyond just, blocking hackers?
Yeah, definitely. So in a typical small to medium business architecture, that device is performing network address translation, or NAT. It's actively maintaining the state tables for every single active session going on. It is the default gateway for your entire internal network. So when that routing engine dies, the internal switches and the wireless access points, well, they might still have power.
But they're useless.
Exactly. They have absolutely no route to the outside world. The entire data plane just halts. You have all these devices physically connected to each other, but logically they are completely isolated.
That sounds like a nightmare.
Yeah.
So knowing the Cisco hardware was beyond recovery, the immediate challenge was selecting the right replacement. And they didn't just grab whatever was on the nearest shelf, right?
No, not at all. This required a strategic architectural decision.
Right, and the source notes that Brandon chose a UniFi gateway from Ubiquiti to replace that dead Cisco unit.
Yeah.
And I'm assuming he did this to consolidate the management plane, because the client already had UniFi access points handling their Wi-Fi.
Spot on. That was the primary driver there. By bringing in a UniFi gateway, he moved the network toward a single vendor ecosystem.
Which makes sense.
Yeah, because the alternative would have been maintaining a multi-vendor environment. Maybe putting in another Cisco or a Fortinet firewall, keeping whatever existing switches they had, and running the UniFi wireless on top of that.
Okay, I want to push back on that unified approach for just a second.
Sure.
Because in larger enterprise environments, architects often intentionally pursue a best-of-breed strategy, right? Like
Yeah.
they might deploy Palo Alto at the edge for threat protection, maybe Aruba for the switching fabric, and Cisco for the wireless. And they do that specifically to avoid vendor lock-in.
Right, they want the best tool for each specific job.
Exactly. They want the absolute best hardware for each specific layer. Doesn't consolidating everything under Ubiquiti sacrifice some of that specialized capability?
Yeah.
Like, isn't mixing and matching sometimes a good thing?
That's a really fair point, and you're absolutely correct that large enterprises use best of breed. But we have to contextualize the administrative overhead that comes with that approach.
What do you mean?
Well, an enterprise has a dedicated network operations center, right? They have engineers who are certified in Cisco's command line, Fortinet's interface, Aruba's management systems. But for a smaller business one without a massive internal IT department, a multi-vendor network usually degrades into a fragmented administrative nightmare.
Oh, I see. The classic Frankenstein network.
Exactly, a Frankenstein network. Troubleshooting becomes this huge exercise in translating between completely different management protocols.
So if something breaks, you're just jumping between different screens.
Yeah, think about the workflow of tracing just a single dropped BOIP packet in a multi-vendor setup. First, you have to log into the edge firewall to check the access control lists.
Okay.
Then you have to open a completely different terminal to check the core switch and verify the VLAN tagging is right. And then finally, you log into the wireless controller just to see if the access point is dropping the client.
And none of those systems talk to each other.
Right. None of them natively share telemetry or logging.
So you're literally just manually correlating logs across disparate systems just to find one little misconfiguration.
It's exhausting. But by moving the edge to the UniFi ecosystem, Brandon utilized a software-defined networking, or SDN, approach. The UniFi controller provides a single pane of glass.
A single pane of glass. I love that term.
It's a lifesaver. When you create a new VLAN for, say, the guest network, you just provision it once in the controller. Then the controller automatically pushes that configuration down to the firewall, it trunks it across the switches, and it broadcasts the new network name on the access points, all simultaneously.
Wow. So that drastically reduces the time it takes to resolve an issue during an outage. Like if a port goes down, the topology map in the controller just immediately flags whether it's a physical switch issue or a routing policy blocking the traffic.
Exactly. The components are inherently designed to orchestrate with one another. And the other major advantage of standardizing the hardware, it was actually really demonstrated during the physical installation itself.
Right, because replacing a core routing appliance without causing a whole secondary wave of disruptions for the employees is an art form.
It really is. Getting the new firewall online is only half the battle. The other half is actually getting the client devices back onto the network.
And there's a magic detail in the source material here that I really want to highlight. It mentions that Brandon configured the new UniFi gateway and reset the existing access points. But, and this is the kicker, he mirrored the exact same network names, the SSIDs, and the exact same passwords from the old configuration.
And that attention to detail is exactly what separates a routine fix from genuine business continuity.
It's a huge.
It really is, because in the context of wireless standards, client devices are essentially just constantly looking for a familiar network and authentication handshake. If Brandon had altered the network name or the security protocol even slightly,
Oh, the result would have been catastrophic for productivity.
total chaos.
Yeah, every single wireless device in the building. We're talking laptops, smart TVs, printers, point-of-sale systems. They all would have required manual intervention.
Right, you'd have the office manager running around all afternoon trying to re-authenticate dozens of devices, typing in new passwords.
Creating just a massive wave of internal support tickets.
But because the network environment appeared identical to the client devices, the moment the new gateway began routing traffic and the access points started broadcasting, those devices simply renegotiated their handshakes and reconnected. Automatically. The internal users just experienced a brief interruption, followed by an immediate restoration of services. They were probably completely unaware that the entire core of their network architecture had just been gutted and replaced.
That seamless swap is honestly so impressive. But, it does bring up an inevitable thought about preventative measures. Because the Cisco unit suffered a hard failure, which halted operations entirely. And hardware rarely goes from perfectly healthy to completely dead in a vacuum, right? There had to be warning signs indicating it was failing prior to the actual outage.
Oh, absolutely. We see this pattern all the time. Administrators tend to treat the edge router as a set-it-and-forget-it appliance. They just ignore the underlying metrics.
Until it catches fire?
Pretty much. The source actually outlines 4 specific red flags warning signs that listeners really need to watch out for. And the first major symptom is usually intermittent drops in connectivity.
Okay, so you're talking about like micro outages.
Yeah.
Where the connection just drops for 30 seconds or a minute and then restores itself before anyone can even properly diagnose it.
Precisely.
Yeah.
And the frustrating part is, when you check the ISP's logs, they'll show perfect uptime on the physical line.
Because it's not the ISP.
Right. Those micro outages are often the firewall's internal hardware struggling. It could be state table exhaustion, where the appliance simply runs out of memory to track active connections, so it just drops packets until the table clears.
Oh, wow.
Or it could be a thermal event. The thermal paste degrades over the years, the CPU overheats under a heavy load, and the unit momentarily throttles or even reboots itself just to protect the hardware.
That makes a lot of sense.
Yeah.
And that ties directly into the second symptom mentioned in the source, sluggish network speeds. And I really want to dig into the mechanics of this because there is a massive difference between the internet speed you pay the ISP for and the actual throughput capacity of your firewall.
Yes, that is a fundamental distinction, and it catches organizations off guard all the time. They'll go out and upgrade to this super fast, symmetric gigabit fiber connection, but their internal network still feels incredibly slow.
Right, because modern firewalls aren't just, reading the address on the outside of a letter and passing it along. They're actually opening the envelope.
Exactly. They are performing stateful packet inspection and often deep packet inspection, or DPI.
Wait, so it's actually looking inside the file.
It is. If you're downloading a file, the firewall is breaking that traffic down, inspecting the payload for malware signatures, checking it against intrusion prevention rules, and then reassembling it before it reaches your computer.
And that level of inspection has to be incredibly CPU intensive.
Extremely. So if you have an older firewall with an outdated processor, it simply doesn't have the horsepower to inspect traffic at gigabit speeds. When you turn on those advanced threat protection features, the CPU just pegs at 100%.
So the appliance itself becomes the bottleneck.
Exactly. Your ISP might be delivering data at a gigabit per second, but your old firewall can only process and route that data at maybe 200 or 300 megabits per second.
So the sluggishness isn't a lack of bandwidth at all. It's literally a processing queue backing up at the edge of your network.
Exactly.
Which perfectly brings us to the third factor, sheer age. The source mentions units running for 5 or more years are basically on borrowed time. And I imagine that's not just about capacitors failing or processors slowing down. It has serious implications for the security posture of the network too, right?
Oh, absolutely. The hardware lifecycle is intimately tied to the software and security lifecycle. Eventually, manufacturers designate older hardware as end of life or end of support. And once a unit hits that status, the vendor completely stops releasing firmware updates.
Meaning they stop patching newly discovered vulnerability.
Yes. And the threat landscape evolves daily. If a new vulnerability like a CVE is published that affects your edge router and the manufacturer no longer supports your hardware, you are basically operating with an unpatchable exploit sitting directly on the public internet.
That's terrifying.
It is, because it doesn't matter how complex or secure your internal network is if the perimeter device itself can be compromised through an unpatched flaw.
And, that assumes the organization even has the ability to log in and apply a patch in the first place. Which brings us to the fourth and final red flag from the source, the loss of administrative access.
Right.
This one seems like more of an operational failure rather than a hardware one, but the impact is just as severe, isn't it?
It's the ultimate form of configuration drift. Over time, internal IT staff turnover, maybe you switch third-party vendors, and the credentials to the edge appliances just get lost.
Yeah.
We refer to it as the black box scenario.
It's the black box.
Yeah. The appliance is sitting there routing traffic, but nobody in the organization actually knows what the security rules look like, what ports are open, or what firmware version is even running.
Right. And if you don't hold the administrative keys, you don't actually own the perimeter, you can't audit the rules, you can't optimize anything. And when the hardware eventually does start showing those intermittent drops or CPU bottlenecks we talked about, you have no way to log into the console to even see what's wrong. You are essentially locked out of your own infrastructure until it inevitably fails.
And those 4 symptoms: intermittent drops, processor bottlenecks causing slow speeds, aging out of the support lifecycle, and lost administrative access, those are the exact precursors to the outage Brandon was called in to fix.
Which naturally leads to the conversation about shifting from a reactive posture, just waiting for things to break, to a proactive one. Because after the new UniFi equipment was deployed and the site was stabilized, the source notes the client was highly interested in moving to a managed IT contract.
Yeah, and that transition really represents a maturity leap in how an organization handles its technology.
Definitely.
Because a break-fix model, where you only call IT when something is broken, it essentially guarantees that your next failure will be an emergency. Managed IT services completely change that dynamic by introducing continuous monitoring and lifecycle management.
So instead of waiting for the firewall to drop offline, a managed service provider is actively monitoring the data from the appliance in real time. Like, If the CPU sustains an 80% load for more than an hour, or if the memory usage spikes unexpectedly, the monitoring platform generates an alert before the employees ever even notice a slowdown.
Exactly. Furthermore, the managed provider takes ownership of the configuration backups and the security patching. They maintain all the documentation, ensuring that lost login black box scenario never occurs.
Right.
And they track the age of the hardware so they can plan the budget for a replacement unit months before the existing hardware reaches end of support.
It transforms IT from this unpredictable, scary operational risk into a manageable, predictable process. Because, let's be honest, a scheduled hardware refresh completed at 2 in the morning on a Sunday is vastly superior to a desperate scramble to find a replacement router at noon on a Tuesday that payroll is trying to process.
Unpredictability is the enemy. Predictability is the ultimate goal of network architecture.
Absolutely. So for you listening right now, especially if you're running operations here on the island, if you're experiencing those micro outages, if your internet speed isn't matching what you're paying the ISP for, and if you honestly have no idea when your firewall was last patched, those are systemic risks. Cowabunga. Computers helps homes and businesses all across Oahu with computer repair, managed IT, networking, and IT consulting.
They do great work.
They really do. The technicians, like Brandon, deal with these exact scenarios daily. You can get a clear picture of your network's health by having them run an assessment. So reach out to their team at 808-468-4411 or visit them online at www.smartcows.com to ensure you aren't just waiting for a critical failure to force a sudden hardware upgrade.
Because addressing those vulnerabilities proactively is always less disruptive and, frankly, less expensive than recovering from a hard-down scenario.
Without a doubt. All right, let's distill the key architectural takeaways from today's analysis. We examined the realities of the demarcation point and how a dead firewall immediately halts all internal routing and external connectivity, even if the ISP is fine.
Right. And we explored the strategic value of consolidating your hardware using a software-defined networking approach like UniFi, rather than maintaining a messy multi-vendor environment that just increases your administrative headaches.
We also detailed the mechanics of a seamless hardware swap, like how important it is to mirror the network names and passwords to ensure all your devices reconnect without any manual intervention.
A huge time saver.
Massive.
Yeah.
And finally, we unpack the physical and operational symptoms of hardware degradation, from CPU bottlenecking during deep packet inspection to the serious security liabilities of aging firmware and lost admin passwords.
It really is a stark reminder that the little flashing box in your telecom closet is actively controlling every digital interaction your organization has with the outside world.
It really is.
And, I want to leave you with a final thought to consider regarding your own infrastructure. We focus heavily on the edge gateway today, but complex networks are full of single points of failure.
Oh, yeah.
So think about your core switches, or your primary DNS resolvers, or even the servers managing your employee logins. What other critical silent appliances are operating in your environment right now where the administrative access is maybe undocumented, or the hardware is aging past its support lifecycle, and a sudden failure would just completely paralyze your operations?
That is a serious architectural question to evaluate. Like,
Yeah.
are your systems actively managed, or are they just black boxes waiting to fail? Well, thank you for joining us on this deep dive into the mechanics of network hardware and proactive management. We will catch you on the next one.